The VSEPR theory from grade 11. Starting off with the full form. So what does VSEP and R stand for? So VS together is what we call as valence shell. Electron pair repulsion. So valence shell electron pair repulsion is the full form for VSEPR. Now let's look at what does it mean. Valence shell means the outermost shell of an atom. Suppose if we take hydrogen, in the structure of hydrogen, there is just one valence shell. So this electron in the outermost shell of the atom is what we call as valence shell. Now electron pair, valence shell, electron pair. Electron pairs means that two electrons are together. So if there are two electrons, that is for helium, this is the structure of helium. So there are two pairs, there's one pair of electrons. This is what we call as an electron pair. Repulsion means pushing away. So the way at which these two electrons push each other away, that is repulsion, or in the way in which they repulse, is what we call as VSEPR. So the theory simply says the electron pairs around the central atom repel each other and arrange themselves as far as possible to reduce repulsion. So the way in which the electrons are arranged in the outermost shell to avoid repulsion is what this theory talks about. So the first topic that we'll be covering are the types of electron pairs. So there are mainly two types of electron pairs. Number one is bond pair. So what is meant by bond pair? So just as the name, bond pair are the electrons that are shared between atoms to form a chemical bond. For example, in methane CH4. In methane, every hydrogen shares electron with carbon. So this is what we call as bond pair. That is C, then H, H, H and H. So as you can see here, all the hydrogens share a bond with C. So these bonds are called as bond pairs. So that is bond pair. And the next type of pair is the lone pair. Lone pair. So what is lone pair? Lone pair means that these electrons are not shared. That is, they stay on the central atom, and these are called lone pairs. That means to say that there is no one or nothing to be attached to, or there is no bond, then those electrons are called as lone pair. Now there is an important thing to remember. The lone pairs, that is whichever compound has lone pair, they occupy more space than bond pairs because they are attracted by only one nucleus. So lone pairs are attracted by one nucleus, whereas bond pair are attracted by many. That is the reason why lone pair has or occupies more space. That means they repel more strongly. So these are the important points you need from this topic. That is, lone pairs occupy more space than bond pairs because they are attracted by only one nucleus, as well as they repel more strongly. Strongly means stronger than bond pairs. So what do you mean by repulsion of these pairs? That is called as the order of repulsion. That's our next topic. Order of repulsion. So what is order of repulsion? So the strength of the repulsion is very important, and the order is when two lone pairs are attached, then their repulsion is greater than a lone pair and bond pair, and that is greater than a bond pair and bond pair. An easy way to remember is this is by this rule. Over here we told that lone pair, they repel strongly. So when there are two lone pairs, that is, so we'll just check the amount of lone pairs and then put it in ascending or descending orders. So here there are two lone pairs, here there is one lone pair, here there is 0. So that means when the number of lone pairs increases, the repulsion is stronger. As the number of lone pairs decreases, the repulsion is weaker. Or you can say, as lone pairs increases, repulsion increases. As bond pair increases, repulsion decreases. The next topic is the prediction of molecular shapes. So this is where we learn the shapes of the molecules one by one. Starting off with two electron pairs. So this is the first shape we need to know. So when there are two electron pairs, that is, there are two electrons around one central atom. So we'll draw one central atom. Two electron pairs, so there is one electron pair over here another one here. So in this, these electron pairs stay opposite to each other. That is, they're on the either side of the central atom. That means to say that they create an angle of 180 degrees. Or you can say that this shape created is called as linear. Why? Because the angle created is 180. So whenever there are two electron pairs, they lie opposite to each other and they create an angle of 180 degree, being linear pairs or linear shaped. Now a common example for this is BeCl2. That is, Be will be placed here, one Cl will be over here, one Cl will be over here. So this is the shape of BeCl2, and this is the example for two electron pairs. The next shape is when there are three electron pairs. So 3 electron pairs means there is a central atom, and next to the central atoms there are 3 electron pairs. So that is one electron pair like this, one like this, and one like this. So here you can see that the angle will be made is 120 degrees, and everywhere it's 120. Over here 120 and over here 120. So since all the sides are equal and they create a triangle over here, see, a triangle, this is called, or the shape is called as triagonal planar. This shape is called as triagonal planar, and a common example is BF3. When you look at the structure of BF3, it will be clearer. You have the boron, and then next to the boron you have one fluorine, another fluorine, and another fluorine. So this is the structure of BF3, and this is an example for 3 electron pairs or triagonal planar. And remember, they create an angle of 120 degrees. The next shape is created when there are 4 electron pairs. So when there are 4 electron pairs, they move as far apart as possible. Why? Because there should not be any repulsion. And that is only possible when it is in 3D. So whenever you hear 4 electron pairs, remember 3D. So how does this or this shape form? So that is, there is one central atom, and next to it on the top there is one electron pair. Over here there is one electron pair, and over here there is one electron pair. The last or the 4th electron pair stays in a way in which it will be behind, not in the front, it will be behind. So that's what is called as 3D. So it will be in a 3D shape, and the angle or the bond angle is 109.5 degrees. This is important. This shape is important, and this shape is what we call as tetrahedral. This shape is tetrahedral, and the bond angle is 109.5 degrees. Now a common example for this shape is CH4 or methane. So we have one C over here, one H will be placed here, one H will be placed here, one H will be placed here, and one will be behind. That is, it will be like this. So that is H. So this is the common shape and the common example CH4 for 4 electron pairs, and they form an angle of 109.5. The next shape is what we get when we replace one bond pair with a lone pair. Now instead of a bond pair, we are replacing it with a lone pair. So now we're going to see what happens. So that is when 4 electron pairs with one lone pair. So the electron geometry remains tetrahedral, but the molecular shape changes to trigonal bipyramidal. The example is NH3. So again, there is a central atom. Now what happens? Now we have 4 electron pairs, and one of them is replaced with one lone pair. So again, just like before, one over here, one over here. Again, one at the back. The last electron pair is substituted as a lone pair. This is how we represent lone pair. Lone pair is represented like this. So this is what is lone pair. So this is the shape of the molecules having 4 electron pairs with 1 lone pair. With 1 lone pair means 1 bond pair is replaced by lone pair. So over here it should have been another atom, but instead of the atom or the bond pair, we introduced a lone pair. So this is the shape that comes. The electron shape is tetrahedral, but since or because of the lone pair, this shape changes to triagonal, pyramidal. Why do we say that it is triagonal pyramidal? It's because again a triangle is created but in the shape of a pyramid. That is in a 3D shape. It forms a pyramid. A common example is NH3. How? N is placed here, an H over here, an H over here, and an H over here, and there is a lone pair. So this is the shape of NH3. This is important, and the angle that is created over here is approximately or becomes about 107 degrees. Again, this is also important. Now, a common question that can arise from these two topics are, why does the bond angle reduce when a lone pair is introduced to 4 electron pairs? It is because when the lone pair is introduced, the lone pair pushes the bond pairs closer together. So when a lone pair comes, it pushes the bond pairs closer to each other. That is why the angle between the bonds become decreased. Now what happens when 4 electron pairs are there with 2 lone pairs? That is, now what we're doing is 2 bond pairs are replaced by 2 lone pairs. So that is the simple meaning. So what happens over here? So we are replacing another bond pair with a lone pair. So a common example is H2O, the water. So the molecular shape becomes bent or angular. So that means there's a central atom over here. Okay, so there are 4 electron pairs. So we'll just draw 2 and 4 electron pairs and 2 lone pairs. So how many bond pairs in total? 2, because 2 lone pairs mean they are replacing 2 bond pairs. So there were 4 bond pairs in the start. 2 are replaced by lone pairs. So in total there are 2 bond pairs and 2 lone pairs. So we are drawing 1 bond pair over here, another bond pair over here. Now the last 2 lone pairs will be drawn like this. So this is the shape. This is called as bent or angular. And the angle between them becomes about 104.5 degrees. So this is important, 104.5 degrees, because the 2 lone pairs, they repel the bond pair strongly, making the angle even smaller than the before ones. Now how is H2O? O will be placed over here, and then we have one H, another H, and 2 lone pairs. So this is how this structure is made, and the angle between them is 104.5 degrees. This is also important. So these are the very important shapes: tetrahedral, trigonal, pyramidal, bent or angular. Then we have linear and trigonal planar. Now let's try some questions to find out the shape of these molecules. The first question is BF3. So draw the B, F, F, and again an F. So this structure is called as the triagonal bipyramidal or pyramidal? No, it is planar. This is when there are 3 electron pairs. The next question is NH3. NH3 means we have an N, then H, H, H. So what about here? There is a lone pair, NH3. So this structure is triagonal planar, right? No, it is triagonal pyramidal. Then we have CH4. CH4, so again we'll draw the structure. There is one C, H over here, H, H, and again an H, yes, and H over here. This structure is called as tetrahedral. So with these questions, we wind up the VSEPR theory. So I hope this video helped, and if this video helped you to understand this topic clearly, please like and subscribe to this channel, and thank you for watching.